In the last video, we looked at adding and subtracting surds. In this video, we're going to look at now multiplying and dividing surds. Let's have a look at the first point. When multiplying surds, we multiply the bases together. Okay, so as an example, square root of 3 times the square root of 7 is equal to the square root of 3 times 7, which is equal to the square root of 21. Now, we've seen this rule before. Okay, this is that rule that the square root of x times the square root of y is equal to the square root of xy. Okay, so I'm just going to go through the proof again quickly. So, for example, if we had the square root of a times the square root of b, this comes back now to index laws. And if you remember the fractional index law, okay, rather than representing these terms with the square root sign, we can use a power of half to represent the same surd. So square root of a times square root of b is equal to a to the power of half times b to the power of half. We could, it's not quite factorizing, but we can kind of factorize the half out. We can express the product a to the half times b to the half with a single index of half. So the a times b can be put inside brackets. A times b is just ab, okay, to the power of half, which is equal to the square root of ab. Now, dividing two surds, same basic rule applies. Okay, when dividing two surds, we divide the bases. Okay, so as an example, square root of 40 divided by square root of 5 is equal to the square root of 40 over the square root of 5, which is equal to the square root of 40 over 5. So notice how the two square roots have now just become one single square root of 40 divided by 5. Now, by the way, the square root also acts as a implied grouping symbol, in fact. So anything inside the surd, we have to pretend that there's brackets inside. Okay, it's a bit like fractions. You might want to remember, so for example, if you had a fraction like this, 1 plus 2 over 3 plus 4, the fraction line, the vinculum, okay, acts like a grouping symbol. So it groups the numerator together, the terms in the numerator together, and it groups the terms in the denominator together. The surd sign behaves the same way. In fact, the top part of the surd sign, this part here, that's also called the vinculum, and kind of acts like a fraction line. It's sort of the same basic or same property in terms of grouping. Anyways, moving on. So square root of 40 over 5, okay, is the same as square root of 8. So 40 divided by 5 is 8. And you know that the square root of 8 can be simplified to root 2. Okay, so hopefully we know how to simplify a surd now by taking out the square factor and taking the square root of that. Proof. Square root of a divided by the square root of b. That's just a to the half divided by b to the half using index laws. The fractional index law there, which is the same as a divided by b to the power of half. Okay. And a divided by b is what can be expressed in fraction form, or is the fraction a over b. Okay, and that's all to the power of half. And then we can express it back into using surd notation, okay, or square root notation, which is square root of a divided by b inside the surd. Right, let's have a look at some examples. Okay. So let's simplify each of these expressions. Okay. So the first one, okay, square root of 3 times 28. Yep. That's equal to square root of 84. Okay. Now, question is, can you take out a square factor? We can in fact take out a 4 from that, can't we? So simplifying that, okay, that's just 4 times 21. Okay, so square root of 84, 4 times 21, which is 2 root 21. Okay, equals 2 root 21. Okay. Again, just check, make sure that you've actually taken out the highest square factor. Sometimes you can take out a square factor, but there happens to be a higher one. Like you could take out 4, for example, but 9 might work, or 16 might work. So always make sure that you check the surd that it is in fact in simplest form. This one is. So square root of 21, well, it's only got 3 and 7 as factors, apart from 21 and 1. So look at part B, 2 root 3 times 10 root 5. You multiply the numbers on the outside first, the coefficients of the square roots. Okay, the number multiplying the square root. So 2 times 10. Okay, actually I might just sort of rearrange the order a little bit here. 2 times 10 times root 3 times root 5. So 2 root 3 just means 2 times root 3. Okay, 10 root 5 just means 10 times root 5. But with multiplication, you can change the order. It's not going to change the answer. All right, so 2 times 10 is 20. Root 3 times root 5 is root 15. Check to see if you can take out a square factor to be able to simplify the surd. Can we? Well, root 15, what have we got? 1, 3, 5, and 15. So none of those are square factors. So that's as simple as it's going to get. All right, what about part C? So 6 root 7 times 3 root 7. Now, we looked at a rule before where if you multiply a surd to itself, the surd basically disappears. So let's do this one again the same way we did part B. So 6 times 3 times root 7 times root 7. So just changing the order of the product terms around. And that's 18 times, that's root 7 squared, isn't it? Right? So root 7 times root 7 is root 7 all squared. Now we've seen this before. Okay, in fact we've discussed this in a previous video. That's 7 to the half squared. So you don't have to show the surd and the square symbol there. So that's really 18 times 7, which is equal to 126. Okay, so if this was a 2-mark question, without a doubt you need to show some working out here. Even if it was a 1-mark question, showing a little bit of working out that shows some understanding, I think that's very important. All right, D, 24 root 180 over 3 root 20. Now there's 2 ways you can do this. You can either just divide them as you see them, okay, or you can simplify the surd first and then do the division as per usual. I don't think it really matters in this case. In fact, it's probably easy enough just to divide the numbers inside the surd anyway. So 24 over 3, so that's just equal to 8. Okay, root 180 over root 20, so that's just 180 over 20. Okay, and that's equal to 8 multiplied by root 9, and that's just 3. 8 times 3, and that's just equal to 24. Okay, so it really depends. Okay, if you wanted to simplify the surd first, you can do that if you like. Okay. Right, what about something like part E? All right, negative root 3 divided by square root of 54. Okay. If you want to, you could, in fact, simplify the root 54. Okay, that's 9 times 6. So you can, in fact, take out a square factor from 54. So you could, in fact, take out the 9 and then take the square root of that, which is just 3 root 6. Okay. In fact, why don't we do that? Just so I can show you something a little bit different here. So that's negative root 3 divided by, now that's 3 root 6, isn't it? Okay, so I've skipped the step of simplifying the 54 to show you the steps in the simplification. I've just simplified it directly there. 3, if you put it back inside the surd, that becomes 9. So 9 times 6 is 54. So we're happy with that. I'm just going to express it in fraction form. So that's negative root 3 over 3 root 6. Okay, so that's going to be a negative 1 on 3, isn't it? So I'm just going to save a bit of space here. That's really negative 1/3 multiplied by root 3 on root 6. Now, I'm going to express that as a single surd. Okay, so 3 on 6 is just 1 on 2, isn't it? All right, so moving on to the next line, that's just negative 1 on 3 multiplied by square root of half. Moving on, okay, sorry, I'm having to sort of save a little bit of space here. So moving on to the next line, that's just negative 1 on 3 multiplied by, now I'm going to split this surd back up again, because the square root of half is just the square root of 1 over the square root of 2. And square root of 1 is just 1, isn't it? Okay, so that's going to be equal to negative 1 on 3 multiplied by 1 on root 2. And that's equal to negative 1 times 1 is negative 1. And 3 times root 2 is 3 root 2. Okay. So the end result of this one is negative 1 on 3 root 2. Okay, a little bit more working out there required, but nevertheless, you're still using the same ideas and the same the same basic principles here. Okay. Right. So look at part F. So 6 root 2, okay, times 5 root 12 over 12 root 8. Now, again, you could simplify the surds first if you like, or just multiply the surds together and then divide it by the surd at the bottom. It really doesn't matter. It's whatever you think sort of, I guess, comes easier or comes more naturally to do that. However, you don't want to go about things the long way unnecessarily as well. Okay, so that takes up too much time. So let's see. I think what we could do is we could just I think we can multiply the surds together here. 2 times 12 is 24. 24 is divisible by 8, and I think that's definitely a lot easier. So why don't we do that? In fact, we could even simplify the 6 and the 12. So get rid of the 6 and make that a 2. Okay? And I can do that because everything, the numerators, basically the two terms in the numerator being multiplied together anyway. Okay, if there was a plus sign there, you'd have to factorize it out first. Okay, the 6 out. But it's not factorized. You don't need to factorize it in this case. Right, so that gives us root 2. So we've got 2 root 2 times 5 root 12. So that's going to be 5 root 24 over 2 root 8. Okay, so the 5 on 2, well, that can't be simplified any further, but root 24 on root 8 is just root 3, isn't it? So that's just going to be 5 on 2 multiplied by square root of 24 over 8. Okay, and that's equal to 5 on 2 multiplied by, now 24 on 8 is just 3, isn't it? So it's going to be square root of 3. So expressing that in a single fraction, it's going to be 5 root 3 over 2. Right, let's have a look at the last one now. So part H, 12x cubed divided by x root x. Okay, what's maths without some abstract algebra? Okay, it can't all be numbers. All right, so do the same rules apply when we're dealing with pronumerals as well. And of course, it does. Okay. In fact, this one might look a little bit difficult or might look tricky to start off with, but you'll find in the end it's actually not as bad as all that. In fact, the first thing I'm going to do is I'm going to bring the x back inside the surd. Okay, so that's going to be equal to 12x cubed divided by, now if I bring the x back inside the surd, it actually becomes x multiplied by x squared. Hopefully you can see where this is going. Right, that's 12x cubed, the square root of 12x cubed, sorry, divided by square root of x cubed. We can express this as a single surd, so that's 12x cubed over x cubed. And the x cubes from numerator and denominator will cancel. Okay. You end up with the square root of 12, and of course we can simplify that. That's equal to 2 root 3.